We recently looked at some intro to statistical information about measures of central tendency, and that involved median, mode, mid-range, but those really don't tell a full picture. As a teacher, I may have two different classes of the same material, different sizes, and these scores are made up, but suppose that I give all of my students in two classes a test. And we have the Class A test scores and the Class B test scores. Measures of central tendency give you an idea, and if the values for the mean and the mode were really packed closely together, as well as the mid-range, that would be a really strong indication the classes were performing the same. But here in this example, both of these classes have a mean of 75. Which could sound like the classes are performing equally well. However, the mode for Class A is 100, whereas Class B is bimodal with both 75 and 81. Since 100 is higher, it sounds like Class A performed better. Now the mid-range for Class A is 62.5, and for Class B, it's 73.5. And that alone makes it sound as if Class B performed better. So what else can we look at to see what this data is really indicating? Well, the next thing we look at is actually the spread or dispersion of data. And that refers to how closely packed the data values are about the mean. So when we consider how those test scores were, how close to the mean of 75 did the students actually score? And we can start to look at, well, this one's exactly the mean, exactly the mean, exactly the mean. But this one was quite a bit under, and yet this one's quite a bit above. So we just start to look at them as a group. Now we have a method for doing that very meticulously and not just guessing and saying they're kind of close or they're not close. So that's what we're going to look at in this lesson. Now, one of the considerations we'll look at is just range. What is the highest value minus the lowest? And that kind of gives us an area that these values are spread out across. Again, these were the scores. So if we're going to find the range, Class A has a range of 75 because the high value of 100 minus the low value of 25 is 75. So that means we had 75 different points across that we spread these scores. Looking at the range for Class B, we have the high value of 81 minus the low value of 66, and those scores are really packed together. Now, this could mean that the students in Class B all have similar skills or backgrounds, and that Class A is simply more diverse. But every little piece of information we gather tells us a little bit more about what our numbers mean. Besides the range, we look at this deviation. Deviation is how far the individual value is from the mean. And so when we look at an individual value, the value itself is x, whereas the mean from a sample is x bar. I have pre-filled in some of this information. If you look at Class A, the numbers and scores from Class A are in this left-hand column, x, and then I subtracted 75, the mean, to find out how far they were from it. When you see a negative display, it tells me that that value was below, and then a positive display indicates that the value was above the mean. So I can see at a glance here that the difference from the mean went from 50 below to 25 above. And again, that's why we had a range of 75. When we look at Class B, these are the individual scores for Class B. We subtracted 75 again because this class had the same mean. And we see that these are really closely packed in, and they go from 9 below the mean to 6 above the mean, which is, again, why their particular range was so small. Now, when we just look at how far something is from the mean, it still is difficult to compare from one class to another. The example I give is like, you can talk about how great an apple is or how great an orange is, but is it really fair to compare apples to oranges? What we want to do is just make a standard comparison so that we say this is as good as it could possibly be, this one is as poor as it can possibly be, and then we have a way to rank them or to say that how they compare one to another. So if you were to take a statistics class, there is a lot of information you could get about this, but this is not a statistics class. We're simply introducing the idea and finishing up your quantitative skills and reasoning course. So we're not going to go in a lot of discussion, we're just going to move to the formula. Now within a statistics class, there certainly is a lot of technology that can help you calculate this, but it would take us more time to explain some of it than it would be just to crank out the few problems you have for this lesson. So that's what we'll do. Our standard deviation is equal to the square root of the sum. So this weird looking little symbol here is a capital Greek letter called sigma, and we read it as the sum. So it's the sum of the data item minus the mean squared, divided by the number of items minus 1. We're going to use that as we move on to find our standard deviations. Now this is the formula again, but the process to go through is this. Find the mean. This is where you add all the values and divide by how many you had. They may give you the mean, but if not, again, it's going to be add and divide. So you add all the x values and you divide by how many there were. Now the deviation is how far a particular value is from the mean. So once you find the mean, that is typically from a sample x bar. For step 2, we will say the particular x value minus x bar. Then after we do that, we square those values. So it'll be the answer to whatever x minus x bar is squared. Then add those squares and divide by n minus 1, and then find the square root. So I'm going to take you through this process for each of these classes. We have already looked at a column where we had the values and then subtracted those values from the mean. Now I did not in this lesson show how to find the mean, but here I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So to find the mean, I would have added all of these values from the x and then taken that answer, which adds up to 750, and divided it by the 10 values I have. And that's where 75 comes in for this mean right here, the mean of 75. Then I subtracted the means, and we looked at that. That is just the deviation, how far it is from the mean. In this next column I've added, I took each of those values from the second column and squared them. When you square a negative number, if you do that on a calculator, don't forget to put parentheses around it, because if you don't put the parentheses, you will get a negative value and all of the squares should become positive. After I squared each of these numbers, you want to add them. Now I already have that value given here, so when I added those, it's 5,050. Following that, once you add them all, then we're going to do this last step. Now it's 9 rather than 10 because this needed to be n minus 1. That tells me that the standard deviation of this particular class, Class A, was 23.7. I followed the exact same sort of an approach over here. Of course, when we added these, we didn't get the same value, but it didn't matter because we weren't dividing by the same thing. We were dividing by 6 because n was 6. Remember over here, n was 10. I also took each of those values and subtracted 75. Then I squared all of those numbers, added those up. That's where 162 came from. That is the sum of the differences squared. That value went into my square root formula. And again, it's 5 because I had 6 minus 1. So now this is the standard deviation for my second class. Since the standard deviation is 5.7 as opposed to this one of 23.6, that still has to do with what the ranges were. It's not exact, but you see a note down here that data with a larger spread or range will have a larger standard deviation. Now, the reason the standard deviation matters is actually related to a following lesson about the standard normal curve. So we're not quite getting into that yet. Just right now, can we find the standard deviation and see what that means? So what does this tell us? Kind of a summary slide. We started this lesson saying they both had a mean of 75. Class A had a higher mode. Class B has a higher mid-range. And the standard deviations now are what we can find. We're not using these standard deviations a lot, just going through that process of finding the standard deviation. The lists that you have are not extremely long on your data values, probably even fewer than the 10 that I have here for Class A. So just carefully follow those steps. So I'm going to close this by going back to the slide right here. This is the key slide to step-by-step take you through and help you find standard deviation. Hang in there, you're almost done.